Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is Physics 5054 and today we are going to take lecture number 14. In this lecture number 14, we will discuss a very important concept of addition of vectors. Yesterday, I told you that scalars can be added through ordinary arithmetics, that is the simple addition, subtraction, multiplication and division. But here in this case, vectors are added by a special method. Now it depends totally on situations, that which situations you are currently dealing. The first situation of vector addition is addition of vectors along the same straight line. If two vectors are lying in the straight line, then you have to add that simply. Now, straight line doesn't mean that both of them will lie along the same line. Might be one is pointing to the right and one is pointing to the left. In that case, we will take the advantage of subtraction of vectors. But if two vectors are lying in the same direction, then we will take the advantage of addition of vectors. These two cases are discussed here in detail, so let's start the fun. But before that, let me remind you, if you haven't yet subscribed my channel, please subscribe it and share it with your friends, your class fellows and your family members, so they will also get advantage of these very important lectures. Ladies and gentlemen, addition of vectors along the same straight line means that if there is a block, one person is applying a force of 3 Newton on it and another person is applying a force of 5 Newton. Then you will observe, and this is a common observation, that it will move in one direction. Always this is known as a line which is representing the overall effects of these two vectors. It is also called a resultant vector, and resultant vector is always denoted by double headed arrows, which shows the overall effect of the two vectors which are to be added. So in this case, if we are measuring the force, that how much force will be acting on this block, then we have to add by simple arithmetic calculation, that is 3 Newton plus 5 Newton, and that will be equal to 8 Newton. So resultant force on this block will be on the right side. In fact, both are acting along the same line in the right direction, so the block will also move towards the right direction, and that will be of 8 Newton. Here I am writing that the overall effect will be 8 plus 5, sorry, 3 plus 5 Newton, which is equal to 8 Newton. Because it is a vector, so it must have a direction, and the direction of this vector is on the right side. So ladies and gentlemen, these forces are calculated in the first case, A part, when both of them are acting along the same line. In case B, the same block, but the two forces are acting in the opposite direction. One is 5 Newton, which is acting towards right side, and the second one is 3 Newton, which is towards the left side. Now it is a common observation, if a stronger person is applying a force of 5 Newton on this side, and as a comparison, a weaker person is applying a 3 Newton force on this side on the same block at the same time, then you will observe that this block will move towards that direction in which greater force is applied. So 5 Newton is on that side, but we have to subtract this 3 Newton from this 5 Newton. So in this case, it will be 5 minus 3, and there will be a Newton. And when we subtract 3 from 5, it will be 2 Newton. Ladies and gentlemen, yesterday I told you that if there is a 5 Newton force, which is this one, and there is a 3 Newton force which is on this. This is 5 Newton and this is 3 Newton. So you have to subtract this 3 Newton and it will represent this 2 Newton as in this case. So the resultant force in this case is 2 Newton, and because these are the vectors, so you have to specify the direction as well, and in this case the direction is on the right side. So this block will move with the motion of 2 Newton force under the effect of the force of 2 Newton towards the right. Now, ladies and gentlemen, there is a second way of addition of vectors. Yesterday, we discussed that we have to draw a news, create a specific scale according to the given situation, draw the line in the given direction, cut the line according to the given scale, and then we will be able to represent that vector graphically. Here we are using today the practical implementation of that law, which was graphical representation of the which is the graphical representation of the vectors. Okay, ladies and gentlemen, there is another way of addition of vector before that which is given in your book. I want to discuss that as well, so that will clear your path for this. This will look comparatively easy. That method is called head to tail rule. Head to tail rule. Head to tail rules are special type of rules in which we can add two vector. For example, there is a vector which is A vector, and there is a vector which is B vector. And now we want to find the sum of these vectors. Because this is not the same case as it was in this addition of vectors by the straight line. These are not straight line. The first line is a straight line and the second line is the line which is having an angle. So yesterday we discussed, first you have to draw news, in this case as well, and then you have to see what bring the connect according to head to tail rule. There is no need to draw the news in this case, that is for representation of this. So you have to bring this and connect the tail of the second vector to the head of the first vector. Connect the tail of the second vector to the head of the first vector, and then draw a line from the tail of the first vector to the head of the last vector, which will show the overall effect of these two vectors. We are denoting that by R, which is called resultant vector. So in this case, resultant vector will be A vector plus B vector. That is very easy. So you have to measure this by the scale, and then you have to tell the user, the person which is asking the question, that this is the result. One force is applied on this, just like in this case block B, this is block and there is a straight line. One person is having a string which is pulling this block with an angle with horizontal on 40 degree, and that is a 5 Newton force. But the second one is known as the 3 Newton force, which is of 20 degree. And this is given, ladies and gentlemen, on page number 41 of your book. Now this is called addition of vector by law of parallelogram. Acha, parallelogram doesn't mean that it should be a parallelogram like this, which is the concept of math. Parallelogram means if the line is like this, then you have to draw a parallel line. Is in the second case in your book it is given, and we will discuss that also in a moment. So this is also, this line is parallel to this one and this line is parallel to this one. According to that condition, it is called parallelogram, and this line must be parallel to this one and equal in magnitude, and similarly this line must be equal to this line and of the same magnitude and in the same direction. Actual parallelogram is this one about which we are talking in mathematics. But here these black lines are given in your book on page number 41. then it is saying, it is asking that with which force this block will move, because in this case they are dragging it in the same line, it will move like this. But if this is in this line and this is in this, somebody is dragging it here and somebody is dragging it here, then it will move towards the right side. With which force? It is not like that it will move towards like this. It will move just like in this case. There is a 5 Newton force, which is the larger one. There is a 3 Newton force, which is the smaller one. So you can see the resultant will be a larger one. If by ordinary mathematical rule we are adding this 5 Newton with this 3 Newton, then it will be 8 Newton. But as I told you yesterday that it is not the case that 5 and 3 will be 8, but here the answer is 7 Newton. Because I told you not ordinary arithmetic calculation can be used to solve these sort of question. Okay, actually what you will do, you will have to draw a parallel line of the same magnitude of this one and the same direction. This must be equal to this one. And similarly, from that point, you have to draw a parallel line to this line of the same magnitude, and you have to connect this. This must be equal to this. One thing more I want to tell you, that all the distances will be the same. This distance, and similarly all these distances will be the same. So that is why it will call a parallel line. Similarly, these distances are also must be the same, so that this line will be a parallel line to this one. Then from the origin you have to draw a representative line, and it will be till the C. So this is 3 Newton and this is 5 Newton, and it means that when we measure this line with the scale you are having in your geometry box, then you will find that this is a 7, and because it is having double arrow, so it means that this is the resultant vector, and the resultant vector is showing the overall effect. And remember, ladies and gentlemen, that when we calculate this resultant line angle with the horizontal line, it is 18 degree. So it means that this block will move a bit upward with 18 degree, because this force is less when you are dragging it in this direction, and when you are dragging it in this direction, it will not go straight line, it will go representing this line like this with the angle of 18. So the resultant vector is making an angle of 15. Ladies and gentlemen, why I discuss this head to tail rule? This is also, for example, if this is 1, I am representing this line, and then I am representing this line here. So according to head to tail rule, because this is O, and you can see that this is A and this is O and this is B. So the first vector is that one. So you have to bring the second vector tail to the head of the first vector of the same magnitude and in the same direction, and then you have to draw a representative line from O to the C part. So you can see this line and this line according to head to tail rule or according to the parallelogram are giving you the same answer. I drew these lines free-handedly. But if you are drawing on a graph paper, then you will get that this is 7 Newton. Similarly, you can get from here 7 Newton as well. So in both the cases, you will get the same answer. Ladies and gentlemen, there is work example 3.2. There is work example 3.2. Work example 3.2, which is also on page number 41. They are saying that there is a block which they denoted by M, and there are two forces acting on this. One is horizontal and one is vertical. They are mutually perpendicular. They given this as 20 Newton and this is in this direction, and the second one they given is 15 Newton. So this is 15 Newton. If there are two forces acting on the block M, one is dragging, this person is dragging it in this particular direction, and this person is dragging this in this particular direction upward. So in which direction it will move this mirror? The main purpose is this one. Ladies and gentlemen, you have to represent these lines first in the same way as this one, and this is 20 Newton, and I am drawing it in another color, and that is 15 Newton, which is a bit less than this. This is 15 Newton. Now, because they are making 90-degree angle, so you have to draw a parallel line to this one of the same magnitude and parallel to it, not with at an angle. And similarly, you have to draw a parallel line of this, which is in this direction, and that is also in this direction. This line must be equal to this line in magnitude and in the same direction, and this line must be equal to this line in the same direction and in the same magnitude. So from the tail of the vectors, you have to draw a representative line, and that will towards the head of the last vector, and that vector is called resultant, and resultant vector is always giving you the overall effect of these two vectors. So then you measure it, and in the book it is given that this will be 37 degree, and you can confirm that by cross checking. and that will be 25, resultant will be 25 Newton. If you are adding this 20 with 15, it will be 35. But the resultant vector here, when you measure it with the scale, then it will be 25 Newton. So it means that this block will move with the 37 degree on this way. So there will be a 27 degree and it will be moving in this particular direction. So that was another, and that is what I told you, that this is also parallelogram. Parallelogram means parallel line, opposite side are parallel to each other. This is parallel, it is rectangle, but because the lines are parallel, so in physics terminology we are saying that this is a parallelogram, but actual parallelogram is this one which we are dealing inside the mathematics. Okay, ladies and gentlemen, there is a challenge on page number 41. This is on page number 40, and that challenge is on page number 41. Whenever I am teaching this topic, then students are, I am giving this as a challenge to the student. If you understood this part, then you can do this very easily. There is nothing. But when the other day the students are coming, they are saying, we are not being able to do that, sir, please do it for, I am doing for you people. I am not giving you this as an homework. Okay, there is a lorry on which there are two forces acting. Jeep is pulling this with 3000 Newton, and here with the same angle with the horizontal, that is 20 degree, and this is also 20 degree, and this is also pulled by the second Jeep by 3000 Newton. So this lorry will move in, ladies and gentlemen, note one thing, that in this case two forces are different, so it will move with an angle. In this case the two forces are having a little bit difference, so it is moving in this direction. This block will move in this, not straight line is this one, which is a horizontal axis. In this case also the forces are different. In this case also the forces are different. So it is moving on one side with the angle. But in this case, because the forces are equal, then it will move. I denoted this not given part. This black part is given. The one I denoted with the black, that is. Now, this line you have to draw the same line here, parallel to this one. This must be the same. This must be the same. Let me tell you, when you are doing practical work, ladies and gentlemen, I am telling you the way. People are drawing it freehanded, but that is not the correct way. Note this line and then put the scale and make a dot here. Then put the scale here and put a dot here. And then connect that line of this magnitude. Similarly, this line is given. Measure it, and here also put a line of this and then make this line. Measure this one, then another point, this point, and this one. So when you are connecting this, Don't make this point because you don't know in advance that how much will be this line. So when 2 points are there, 2 points are enough for one line. So ladies and gentlemen, then measure this line and extend this line till the length of this line, and then connect this one. So you will see that this will be a straight line. So it means that this lorry will move in the straight line. It will neither go in this direction, neither it will go in this. As in this case, because 5 Newton is more, so it is going in the 5 Newton a bit. Is this is 90 degree, so it will go towards the 20 Newton force. It is not going upward, it is going a bit this one. This is also dragging, and this is, so it will go in this dash dash line direction. But in this case, both the forces are equal, 3000 Newton and 3000 Newton, pulled by the jeep, pulled by the jeep. So you have to complete the parallelogram. They are parallelogram, we are calling it. But if technically we are seeing this in mathematics, that this is rhombus then. But in mathematics we are calling it rhombus, this is parallelogram. But for addition of vector, it is not that physics is violating the rules of mathematics, but means parallel lines I should say, instead of the parallelogram, because then you will be confused. So parallel lines and parallel lines, they are making different shape, but this will be equal in magnitude to this one, and this will be equal to in magnitude to this one. Then you have to measure this line, and whatever line you are getting, that will be the answer. Ladies and gentlemen, that's it for today. Revise it, listen the video, share it with your friends and family members, subscribe the channel so you will be notified immediately after I upload the video. Thank you very much for watching. Allah Hafiz.